most important physical unit is thermodynamics. What is thermodynamics? And what it explains, thermodynamics? And what are the important factors in this thermodynamics? In thermodynamics, there are two important areas. One is physical aspects, another one is chemical aspects. Thermodynamics in physical processes and thermochemistry in chemical processes. Anyhow, in thermodynamics, thermo means heat, dynamics, motion. Thermodynamics is the branch of science which deals the study of interconversion of energies. During the physical or the chemical process, some interconversion of energies takes place. During this physical and chemical process, certain chemical, physical changes, certain energy transfers. In this thermodynamics, thermochemistry is the branch of thermodynamics which explains the energy transformation during the chemical processes, is called a chemical thermodynamics. Anyhow, here the importance of thermodynamics. Importance of thermodynamics. In this importance of thermodynamics, just this thermodynamics, first important point is it explains the feasibility of the process. Feasibility of the process is nothing but possibility. Is it possible or not? Possibility of the process. So the importance of thermodynamics, the feasibility of the process or the reaction. Second thing is here to deduce or to reduce, or to calculate some important thermodynamic laws like Weintraub's law, depression in elevation in boiling point, depression in freezing point, are some important laws we can easily deduce by using thermodynamics. And here are some important limitations of thermodynamics. Limitations of thermodynamics. Just thermodynamics explains only feasibility or the possibility of the process, but not explains here the how it follows. So here the thermodynamics explains only here the state of the system, not a path of the system. That's why one of the most important limitation is here it explains only feasibility, and it depends on state, that is initial and final state of the system, but not on a path followed by the system. And here thermodynamics explains the macroscopic properties of the system, but not a microscopic properties of the system. So on the basis of importance and limitations of thermodynamics, here are some important questions are raised here. We would like to answer some important questions on the basis of thermodynamics. That is, how we do the energy transformation, energy changes during a chemical process. Is it possible or not? And how to determine the energies in a physical and chemical processes. And the process possible or not. So these are some important questions arise in thermodynamics. So to answer for all these questions, here we want some important basic technical terms. So just I'll introduce some important basic technical terms. Then I'll explain some important theorems and important derivations. So anyhow, here the important technical terms, thermodynamic terms. Important terms in thermodynamics. Important terms in thermodynamics. In thermodynamics, one of the most important term is system. Another one is surroundings. Surroundings. Third one is boundary. So, my dear students, what is a system? So, what is a system in thermodynamics? Generally, anything in the universe except the surroundings is generally termed as a system. So, here the system is the part of the universe. Part of the universe which is investigated under thermodynamic properties. System is the part of the universe which is investigated under the thermodynamic properties. Here are the surroundings. Next important point is surroundings. Surrounding also part of the system other than system. So it is also part of the universe other than system, that is surroundings. Sorry, here system and surroundings, these in the universe, system and surroundings separated by a real or the imaginary boundary or the wall or the line, that is called a boundary. That boundary is the real or the imaginary which separate the part of the universe, that is system, and other than the part of the, that is system, part of the universe other than the system, that is surroundings. That's why here the universe is equals to system plus surroundings. So this is universe is equals to system plus surroundings. Now the system and surrounding separated by a real or the imaginary boundary, one line. So that real or the imaginary line which allows or which keeps the, which control the energy transformation in and out of the system to the surroundings, surrounding to the system. That's why these are the three important basic technical terms present in thermodynamics. So along with system, surroundings and boundary, there are some important different types of systems. So in different types of systems, here on the basis of composition of the system, on the basis of movement of the particles present in the system, they are classified into different types. So are they on the basis of composition, composition of the system, these are mainly classified into two types. So on the basis of the composition of the system, one is homogeneous system, and another one is second one is heterogeneous system. These are the two important systems. What is homogeneous system? What is heterogeneous system? So the homo means already in second year surface chemistry we know homogeneous catalysis and heterogeneous catalysis. Now same way here homogeneous means that is in same phase. Heterogeneous means they are in different phase. So the homogeneous system nothing but it is a type of system in which throughout the system same composition is present. That is, in surface chemistry colloids path we know true solutions. One of the most important concept in surface chemistry are the true solutions, suspension and colloids are there. True solutions are the one of the most important best example for homogeneous system. And also here one of the most important pure solids or liquids or the gases are the best example for homogeneous system. It is a type of system in which throughout the system uniformly distributed, same type of composition, same type of particles present in it. That is called a homogeneous system. But here the heterogeneous means different phase. They are indifferent. For example, here the solid ice is in contact with water is the best example for this heterogeneous system, because they are in different phase. Because here the ice, that is H2O, is in a solid state, that is in equilibrium with water is a liquid, that is taken on closed vessel. Now it is in equilibrium with each other. Now here ice is solid and water is liquid in different phase. And also the different insoluble liquids in other different insoluble liquids, two different insoluble liquids or different solids are the best examples for this heterogeneous system. Okay. Here on the basis of composition of the system, here are the two important systems, homogeneous and heterogeneous. On the basis of these two important points, maybe very simple silly questions they'll ask in a competitive examination, that is, which of the following is the best example for a homogeneous or a true solution or a heterogeneous. So we can create so many examples on the basis of these two important simple points, homogeneous and heterogeneous. We can cover these important points already explained in surface chemistry, catalysis, and also here in thermodynamics first year. The next one is on the basis of movement of the particles, are on the basis of movement of the particles, again systems are classified into different types. That is, your first one is open system. So what is open system? Anybody? All are in online? So here open system means It is the type of system in which both matter and energy can exchange from system to the surroundings. Already starting itself explain what is a system. System is the part of the universe under the investigation of thermodynamic conditions. Such a system is an open state, open nature. So for this open system is the type of system in which in thermodynamics both energy and matter can exchange. So in this system, best example, now time is right now 3:25. All are eagerly waiting for a tea break. In that tea cup, better you take a cup of tea or coffee like this. This is cup of tea. This is. So it is the best example for open system from which both here the matter and heat both can exchange. So in the form of these vapors, some amount of water vapor or some amount of in the form of water vapors or coffee or milk, in terms of liquid in vapor state, vaporize, movement of the particles takes place, and also from here heat transfers. So from the system both matter and energy can exchange. Such as systems are open system. Generally all naturally available plants is the best example open system easily. So it can exchange both energy and matter like. So after this open system, next another important thing is, another important system is, it is a closed system. So in this closed system, we know already system story. So in this closed system, not a this open vessel, take a battery, take your closed vessel. In this closed vessel, battery, you take iodine I2, this is I2 solid. This I2 iodine solid is heated at certain temperature. So it is completely closed. Yeah, there is no any open area. This iodine I2 solid on heating slowly vaporizes and converted into iodine vapors, I2 vapors. But these vapors cannot escape from the system. Only continuously revolves in a closed system, iodine vapors, but during this heat, by absorbing some amount of heat from this, only heat transfers, Q only transfers, but not the matter. So the closed system is the type of system in which only heat only transfer, but not the matter. Such systems are called closed systems. So after this open and closed system, another important system is most important system is isolated system. In this isolated system, compulsory battery you take thermally insulated system, that is compulsory closed. Thermally isolated system means this is the thermally isolated system. Now, just like a thermos flask, now it is completely insulated system, perfectly insulated system it is. Now, in this battery you take ice, that is a solid water, H2O. From this, it is converted into a liquid, but from this water vapors and heat cannot exchange. Means, in an isolated system, it is a type of system in which neither matter nor energy, or it is a type of system energy and matter cannot exchange from system to the surrounding. It is a surrounding. It is a system. Now it is a system. From this, energy and matter cannot exchange. Such a systems are called isolated systems. So anyhow, on the basis of composition of the system, there are two important, main important systems are there. One is homogeneous system, another one is heterogeneous system. Clear? Then, on the basis of movement of the particle, there are three important systems are there. One is open system, closed system, and isolated system. Here, on the basis of movement means matter and energy or mass and energy based concepts. Okay, clear. Next one is after some important systems, types of systems, here are some important thermodynamic processes are there. Thermodynamic processes. So the thermodynamic process means by using some important systems, homogeneous or heterogeneous, open system, closed system or isolated system, there are some processes takes place during a physical or the chemical processes, some energy transfers, energy changes. So in this thermodynamic, in this process, what drives, what energy means, what it drives the required amount of energy to transfer from one state to the another state. By using this process, we can easily explain. So in thermodynamic processes, one is isothermal processes. What is isothermal processes? Iso means equal, remains constant. Thermal means temperature. So it is the type of process in which temperature of the system remains constant. There is no change. But maybe other factors, other parameters may be changes. But in this case, the temperature remains constant. T remains constant. Temperature remains constant means in initial state, how much temperature is there, and in a final state also same temperature, that is, or take care of the T1 and T2. In these cases, both T1 and T2 both are same. So is the type of process in which there is no change in their temperature during a physical or the chemical processes. Such processes are generally called isothermal. By using this, in this, the change in temperature delta T is equals to T2 minus T1. Both are same. That's why here this value is equals to 0. Now delta T or dt is equals to 0. But remember here, one of the most important thing is here. This point we know for all while reading this, but here regularly, but in this process, here the dq is not equal to 0. Very, very important. While doing isothermal expansion of an ideal gas, in isothermal process, temperature remains constant, but heat is not constant. There is a change in their heat. Even though temperature remains constant, but there is a change in their heat. That's why dq is not equal to 0. Yeah, important thing is, this is very, very important. Now here the delta T is equals to 0, but del Q is not equal to 0. This is one of the most important process. So isothermal process is a process in which temperature remains constant. That's why this value is equal to 0, but not equal to this. Delta Q is not equal to 0. Okay, clear? Next one is, after this isothermal process, here one of the most important process is adiabatic process. So the adiabatic process, in this adiabatic process, so are the process either a physical or a chemical process, just like in isothermal, here also in adiabatic process. It is a type of process in which the heat remains constant. Heat Q remains constant. There is no change. Means here heat in initial state is Q1, and in final state is Q2. Both are same. Here Q1 is equals to Q2. So the change in heat, that is dq or delta Q is equals to, we know here Q2 minus Q1, here both are equal, that's why is equals to 0. But here one of the most important thing is, in this process delta T is not equal to 0. These are very, very important. In this we know delta T is equals to 0, but dq not equal to 0. But whereas in adiabatic process, here the heat remains constant. It is a type of process in which, while doing some chemical or the physical process, your heat remains constant, but temperature is not remains constant. Something is there. That's why your dq or delta Q is equals to 0, but delta T not equal to 0. Such processes are called adiabatic processes. So anyhow, here in this two important process, better just a glance, just remember your dq is equals to 0, but delta T not equal to 0. Next, third important process is your isobaric process. So in this isobaric process, iso means we know already, remains constant, same. Here the word is bar, that bar is here generally unit of pressure. Bar, Newton per meter, atmosphere, pascals, are some important units of pressure. Isobar, isopressure. Isopressure means in this process pressure remains constant. So it is a type of process in which pressure remains constant. Maybe other important variables, maybe volume, temperature, maybe some other important composition, maybe varies, changes, but here pressure remains constant. That's why here dP is equals to 0. Now fourth one is here isochoric process. In this isochoric process, chor is nothing but volume. Isochoric, chor is nothing but volume. Iso means same, remains constant throughout the process. That's why the type of process in which volume remains constant. Now here the dV or delta V is equals to 0. So the isothermal, adiabatic, isobaric and isochoric process. So by using these four important processes, there is an important graphical representation in thermodynamics, thermodynamic processes. there is a pressure volume relation, important PV graph is there. So on the basis of all these four important processes, so on the basis of your isothermal process, adiabatic process, isobaric process, isochoric process. So on the basis of these four important processes, there is a PV graph, pressure volume graph. So graph is plotted between pressure versus volume. Now it is a system, for example, one system. In this system, maybe process takes place from here to here like this, here to here. So the volume, something here volume is there, that volume is maybe 1 liter. But your pressure is maybe 10 atm or 10 atmospheric pressure. Here 7.5, here 5, and here 0 atmospheric pressure. So here there is one important, your pressure is not constant here, but here the volume is remains constant at 10 atmosphere, at 7.5 or 5 or 0 whatever rate, your volume is 1 liter only. So what is in this graphical PV graphical representation, pressure volume graphical representation, by using a simple line, it is a system. In the system, volume is remains constant at 10, 7.5, 5 and 0. Here it is remains constant volume. What we know by using this isothermal, adiabatic and isobaric and isochoric process. Now here volume remains constant. There is no change in their volume. Delta V is equals to 0. That's why this process is called isochoric process. Now it is isochoric process. Okay, PV graphs, graphical representation. Now here this is the system. Pressure is remains constant at 10 atmospheric pressure only. But here the volume changes. Here 1 liters to the 2 liters, 2 to 3, like volume changes. Now volume is not remains constant. Now at 10 remains constant, volume is maybe 2 liters, here maybe 3 liters and so on. Here volume changes, but here the isobaric pressure remains constant. That's why now it is isobaric process graphical representation. Generally, there is a mechanical work done that is based on PV graphs. Different types of works are there. I'll discuss later in the next session. So in this PV, work is associated with the volume changes from initial state to the final state. At constant external pressure, the work done is nothing but a mechanical work done. In that mechanical work done, generally among these isothermal and adiabatic process, that work done is maximum in isothermal processes. Maybe at constant pressure and volume, among this isothermal and adiabatic process, the maximum work done is in isothermal processes maximum than compared to the adiabatic process. That's why here there is an important graphical representation here. So I'll take here directly two important graphs like this. Now among this we can decide it. Here a little bit confusion. Now by taking the work like this, work graphical representation here, we can take a graph like work. Now this is the work for certain process. This is the work graph for certain process. But here maximum work is there. That's why we can consider it is a isothermal process. But it is a adiabatic process. Clear? Now here PV graphs based on this, based on processes. Here four important processes: isothermal, adiabatic, isobaric and isochoric. PV graphical representation. Maximum in physics, also in thermodynamics, maximum will ask questions based on graphical representations. Work related PV graphs. But right now, up to 2019, in NEET or in other KCET examination, in chemistry, there is no such a PV graphs. Maybe we can expect next year, like next year for our batch, we can expect one question based on this. Not only one, like so many PV graphs are there, we'll discuss later. Like we can design PV graphs by using some related important processes. Okay. So after this isothermal, adiabatic, isobaric and isochoric, again three important processes are there. That is a cyclic process, reversible process and irreversible process. Now here the another important is fifth one is the cyclic process, reversible process, reversible and irreversible process. So are the after this four important processes, remaining three important: cyclic, reversible and irreversible. So any process takes place at one place and it takes place in different ways or different paths and finally comes to its original state. Such any chemical processes or physical processes are called cyclic processes. So in this cyclic process, generally delta U is equals to 0. Delta H are also equal to 0. So the change in internal energy and change in enthalpy must be equal to 0 in cyclic process, because in this process, generally a process start at one place, initial state like this, and it expresses different paths like we'll take A to B like this, and again take B to C, then again it takes place C to D, and again comes to its original state B. Sorry, A. So are the A to B, B to C, C to D, and D to A is the original state. Such processes are called cyclic processes. So in this cyclic process, for example, maybe in initial stage, like A is, for example, pressure P1, volume is V1 at certain constant temperature. To A, B state means A to B, your pressure is P2 and volume is V2. And again it is converted into C, your pressure is P2 and volume is, your pressure is P3, volume is V3. And here D is, pressure is P4 and volume is V4. Then it is final state comes to its again original state. So such a cyclic process in this A to B, B to C, C to D, and again D to A, delta U is equals to 0 and delta H is equals to 0. This is about the cyclic process. Next, come to the next process, reversible process. It is one of the most important process. Regularly we can use in chemistry reversible reaction, irreversible reaction. Reversible process, irreversible process. Now the reversible and irreversible, generally in chemistry we can show like a symbol reversible it is. It is irreversible like this. Symbolically we can represent. So in a reversible process, a process is said to be reversible. Generally, the reactant A is converted into reactant B. So reactant A is converted into reactant B. Why are the reactant is converted into product B? Product B. Here from A to B, while moving A to B, the driving force is more than compared to the opposing force. So the A is a reactant and a B is product. In this case, the A reactant is converted into product. A reactant is converted into product. In this case, there is a driving force. In this, generally, driving force is greater than opposing force. So, whenever to convert A to B, reactants to products, driving force is slightly, that is infinitesimally small than compared to the opposing force. Now, the process carried out in a closed vessel, for example, at any instant of time, slightly, the opposing force, infinitesimally small opposing force is greater than driving force, then again these products are converted into reactants. Such processes are called reversible processes. These reversible processes are not real in practice, imaginary only. But in a reversible process, maximum work is done. It is imaginary. So we can't calculate, we can't see the real in practice, such a reversible process. But here maximum work takes place in these reversible processes. So the reversible process is a type of process in which initially, infinitesimally, at certain state, driving force is greater than the opposing force. After certain time, in a closed vessel, this infinitesimally increase the opposing force, then compared to the driving force, comes to its return, then again products convert into reactants. Such chemical processes are called reversible processes. But finally, last one is irreversible process. So it is at finite, not infinite. At finite time, directly, the reactants convert into products, means in this case, always, the driving force is greater than opposing force. Directly converted into products, reactant converted into reactants, cannot return to its original state. Such processes are called irreversible processes. Okay, so these are some important technical terms present in thermodynamics. Once again, we'll revise, recollect within just glance, 2 minutes. Just introduction, system, surroundings, boundary, types of systems, homogeneous, heterogeneous, and open system, closed system, isolated system. Then some important processes. There are isothermal process, adiabatic process, isobaric, isochoric, cyclic, reversible and irreversible process. Tomorrow, next section, at the same time, we'll meet. and we'll discuss a very important guarantee, confirm. We can expect one question either in physics or in chemistry. That is macroscopic properties of the thermodynamic systems. So thermodynamics initially itself explained, thermodynamics deals with the macroscopic properties, not the microscopic properties of the system. So tomorrow we'll discuss one of the most important concepts, properties of the system, that one of the most important concept, that is intensive property and extensive property. Regularly in KCET one question, every alternate year one question will ask. Or in JEE, we can expect one question. They will collect the group of intensive and extensive properties. Then how many intensive and extensive properties are present in this? Guess it. Such questions they will create. And how we can convert the intensive to the extensive to the intensive. Tomorrow we'll discuss. Okay? Take care. All the best.